Good evening, students. Good evening, everyone. Welcome to Mindworks. I am Deepanshu Agrawal. We will be having this live assessment as promised. We have already done two sessions on this. So, this is the third one in continuation with those two. Okay, so in this session, what we do is see, I have given you six questions as you can see on the screen. May not be the case that all six are visible. Just let me show each and every question to you. Okay, so now the topic is time, speed, distance, and I'll be giving you these six questions, and you would be getting 2 minutes per question to solve this. So this can be considered as a short assessment also. So for solving these six questions, you would be having a time of exactly 12 minutes, right? So in those 12 minutes, you have to figure out which question to solve, which question not to solve, and which question to solve first, which question to solve later. Okay. So it's 11:03 exactly now. So I hope you have copy and pen with you. So you can start the questions from question number one onwards. Exactly 12 minutes later from this, that means at 11:15 we'll stop and we'll assess how much we were able to solve, how many questions we were able to solve, and then I'll be giving you the answers as well as the solutions of these six questions, right? So keep your copy, keep your pen, and start with the questions. Those who would be watching this watching this video as a recording after this live session, so they should also not pause the video. They should also continue with the video with the time that video is taking while we would be silent. So you should be able to solve these questions in those 12 minutes only. Maybe 2 minutes more I can take at the end of the test, at the end of the assessment, but not more than that. You should not keep pausing the video in between to gain some extra time, right? It's a practice session. You have to solve, you have to assess yourself. So it's better to keep it that way. Okay. While I remain silent, you should all be solving these questions. Yeah. Those who have just joined my live session, let me tell you, this would be a short assessment type of session. Take your copy and pen and start solving these questions. Six questions are on your screen. You should try to solve six questions in 12 minutes maximum. Good evening, Vibhor. Good evening. Hi, Sai. Sai Swaroop. This is a live assessment. You have six questions in front of your eyes, and you will have 12 minutes to solve this, out of which I think 2 3 minutes are already gone. So just pick the pen quickly and copy and start solving it. Those who have just joined, it's a live assessment of six questions. You'll be given 12 minutes to do it. Although 4 minutes are already gone, so you just have 8 more minutes. Try to solve maximum questions in those 8 minutes. I hope your copy and pen are with you. If you have just joined, students, this is a live assessment, short live assessment, and you have to solve these six questions within 12 minutes, out of which 6 minutes are already done. So 6 more minutes only. In fact, not even six. It's 11 here. So 4 5 more minutes. That's it. Maximum 5 more minutes. Three more minutes, students. Only 3 more minutes. Ideally, it's the last minute, students. The time should get up in 1 minute, but I'll still give you 2 minutes, two more minutes to solve the rest of the questions. I think you may not be able to. It's because those 2 minutes would be the compensation of the disturbance that you had. Maybe in the starting, you may be not having copy and pen with you. So 2 more minutes, students. Okay. So Vibhor, are you able to do the do all the questions? Can you send me the answers in comments? Okay. So students, the questions are done. The time is also up. Uh, the questions are not done. The time is up. So let me give you the answers. and then we will go for the solutions. Okay. So, yeah. So, the answer for question number one would be 100 kilometer per hour. Change the color, and then just a second, students. Yeah. So, the answer for question number one was 100 kilometer per hour. For two, it should be 10 kilometer. Sorry, 10 minutes. Yeah, it should be 10 minutes. Then for third, the answer should be 5 kilometer per hour. I took 2 hours more than Samir. Yeah, it would be 5 kilometer per hour. For question number four, it should be 12 kilometer per hour. For question number five, it should be 3 is to 4. Yeah. And for question number six, it should be 3 is to 2. Yeah. Okay. Vibor, you didn't miss anything, but I asked you to send the answers on comments, and it's okay. Now you have the answers on the screen as well. So now let's start solving the questions. Question number one. Yeah. So question number one says that a train, आज का टॉपिक क्या है? आज का टॉपिक है टाइम स्पीड डिस्टेंस, as you can see here. And you should be joining a bit early because the assessment part is done. Now we are only having the solution part left, so you should try to join early from the next time. I think the next time also the time speed distance would continue, because time speed distance is not done in these six questions. It is actually way more than that. Okay, so question number one, it says a train can travel 50% faster than a car. Both start from point A and at the same time and reach point B 75 kilometers away from point A. So point A and point B are 75 kilometers apart. So if the speed of the car is c kilometers per hour, c, okay, then the speed of the train would be 50% more than car. So that would be 1.5 times c. I hope you all know the multiplying factor for 50%, for more 50% more, is 1.5, right? Whenever we multiply something with 1.5, it gets increased by 50%. I hope you know that. Yeah. Okay, so this is the speed of the car and this is the speed of the train. Okay, now on the way, however, the train lost about 12.5 minutes while stopping at the stations. Okay, so car was continuously moving till it reached this point, but train has lost 12.5 minutes in between them, in between A and B, point A and B. So we have to find the speed of the car. We have to find the value of the c, right? Now uh, it is also saying, the question is also saying that the car and the train start at the same time from point A and reach at the same time from point to point B, 75 kilometers away from point A, right? So that means that the car has taken suppose t time to reach here. So the train has also taken t time to reach here, but the traveling time of the train is t minus 12.5 minutes, right? Because for those 12.5 minutes, the train has actually stopped somewhere, right? The train has started from point A and the train has reached to point B, but but the train has lost 12.5 minutes in between these 2 points while stopping. So ideally, this 1.5 c speed is when the train is running, not included. It is not the average speed, because average speed would have been same as the speed of the car, right? Because they both start at the same time, finish at the same time, so average speed had to be same. But because of the loss of this, they have been to uh, they have been at the same time. Okay, so that means we have a formula, simple formula, called speed equal to distance upon time. From here we get distance equal to speed into time. We get distance equal to speed into time. Okay, now distance here is given as 75 for both the journeys, for train as well as for car. So this 75 should be equal to the speed of the car into time taken by car to reach from point A to point B. So speed of the car C and time taken by the car to reach from point A to point B. Correct? So this is the first equation. Also, the same distance would be covered by train by a speed of 1.5 times c. The speed of the train is 1.5 times the speed of the car, but train has lost 12.5 minutes. Out of this time, the car has taken t time to reach from A to B, and train has lost 12.5 minutes from this t. So that means if those 12.5 minutes would have not lost, the train would have not lost those 12.5 minutes between A and B, so the train would have reached to B 12.5 minutes earlier than the car. If train would have not lost 12.5 minutes between the journey, then the train would have reached at point B 12.5 minutes before the arrival of the car. So that means the time that the train would have taken was t minus 12.5, right, divided by 60 to make this time in hours. So one c into t, the speed of the car into the time taken by car, right? The speed of the car into the time taken by the car to reach from A to B is equal to 1.5 times the speed of the car into time taken by car minus 12.5 divided by 60, right? So now you just have to consider this part only, right? So ct will be equal to 1.5 c into t minus 12.5 by 60, right? This is the equation. You can cancel c from both the sides very easily, right? So this would be t equal to 1.5 t minus, sorry, this is not equal to, but it's minus 1.5 into 12.5 by 60. Do not solve or multiply any of the expression until it is very much required to do so, right? So from here you will if you calculate correctly, then you will find the value of t. You will find the value of t, correct? Right, and that would be 3 by 4. That means that would be 3 by 4 hours. Okay, if you solve this correctly, you'll get the value of t as 3 by 4 hours. If you put this t into the this equation, 75 equal to ct. If you put this t into 75 equal to ct, so c into 3 by 4 will be equal to 75. So the value of c would be 100. This is how you can solve it, right? Okay, first question is done. Let me take you to the question number second. Question number second is very logical question. It doesn't have any calculations contained in it, but it's very logical. See, it is saying that excluding stoppages, the speed of the bus is 54 kilometer per hour. Including stoppages, it is 45 kilometer per hour. That means if the stoppages are included, so the bus is able to cover only 45 kilometer in 1 hour. But if the bus doesn't stop at anywhere, so the bus would be able to cover 54 kilometer in 1 hour. Okay, right. So if including stoppages, if by including stoppages, the bus is able to cover 45 kilometer per hour. If by including stoppages in the journey, the bus is able to cover 45 kilometer per hour. It's very logical question, students. So please pay attention, please focus. So 45 kilometer per hour, the bus is able to travel. But if if it was not required for the bus to stop, if it was not required for the bus to stop, so see, let's assume it like this, that there's a point A and there's a point B. I'll write point B here, and there's a point C. So the distance between A and B is 45. Distance between A and B is 45, and distance between A and C is 54. Right? So if a bus stops in between, if a bus is stopped in between its journey, so the bus is able to cover only 45 kilometers. But if it is not stopped anywhere, so the bus is able to cover 54 kilometer, and the bus would have reached point C. Okay, so you just have to calculate that how much time the bus would have taken excluding stoppages. This was including stoppages, this was excluding stoppages. So how much time the bus would have taken excluding stoppages to cover this distance of 45 minutes, sorry, 45 kilometers, right? So the time taken by bus to cover 45 kilometer with the speed of 54 kilometer per hour would have been how much? Time is equal to distance by speed, right? Speed equal to distance upon time. So time is equal to distance by speed. So this would have been 45. The distance is 45, and the speed without stopping is 54. 45 by 54, right? This much time would have been taken by the bus to complete the journey. Okay, so if you see this time correctly, so this time would be 5 by 6, right? 5 by 6 hours. If I convert this into minutes, so this would be 5 by 6 into 60 minutes, right? and that would be 50 minutes. So from here we have got one thing, that if excluding stoppages the bus runs without stopping anywhere, so this distance would have been covered in 50 minutes, but including stoppages the same distance has been covered in 60 minutes. So how much time the bus is losing per hour in a span of 60 minutes? How much time the bus is losing per hour? So the bus is losing 10 minutes per hour, right? For how many minutes the bus stops per hour? So the bus stops for 10 minutes per hour. Correct? I hope this is clear. Okay. Question number 3. Question number 3 is also of some similar type. It says that in covering a distance of 30 kilometer, Abhay takes 2 hours more than Samir. If Abhay doubles his speed, then he would take 1 hour less than Samir. Right? Yeah. Now, this Samir is a hypothetical thing. Okay. There is no role of this Samir in this question actually. Why? Because it is saying that in covering a journey of 30 kilometer, Abhay takes 2 hours more than Samir. So Samir plus 2, right? If Abhay doubles his speed, this is Samir, right? If Abhay doubles his speed, he would be taking 1 hour less than Samir. So I would write here Samir minus 1. So initially it was taking 2 hours more than Samir. Now it is taking 1 hour less than Samir, right? So can we say that there is a difference of 3 hours? 2 hours more than Samir and 1 hour less than Samir. Whatever the value of Samir is, whatever the speed of Samir is, there is a difference of 3 hours between these two values, right? And because there is a difference of 3 hours between these two time, so can I just say that if Abhay increases his speed from S to 2S, he takes time he takes a time 3 hours less than the original time. Why we are taking this Samir as a uh, point of measure, right? So yeah, so we can simply say to cover 30 kilometer at the speed of S, uh, at the speed of S the Abhay takes t time, and the at the speed of 2S Abhay takes t minus 3 time, right? So again apply distance equal to speed into time. So distance is 30. If he travels at t, he takes s. Sorry, if he travels as at s, he takes t time in reaching the destination. And if he travels at 2s, he takes t minus 3 time. Correct? So we have to calculate the speed of the Abhay. That's it. So that now it is very simple. It is the same question as this one, almost same, right? We need to take Ts is equal to 2s t minus 3, right? We can cancel this s and s. So this would be t equal to 2t minus 6, correct? So from here you'll get the value of t as 6, right? Yes, Antonio, these questions will be asked in IP mat. Same type of questions would be there. No change, right? For sure, it would be asked in IP mat, JIP mat, and all the BB entrance exams, right? So these are the hot questions which are being asked. Although I can say that these are not up to cat level. Maybe one or two question out of this can come sometimes in cat, but for IPMAT, for CLAT, for campus recruitment, right? Uh, for all these exams, these are very hot questions. Yeah. Okay. So I hope this is done. Where were we? So we have calculated the value of t is equal to 6. Just put it in this formula. Just put it in this equation. 30 equal to ts, and you'll get the answer. Answer would be answer would be 5 kilometer per hour. Okay, it's easy now. Right. Let's go for question number 4. Question number 4 says that Robert is traveling on a cycle and is calculated to reach a point at 2 p.m. if he travels at 10 kilometer per hour. Right. So if, see, distance has to be same. Now if he travels at 10 kilometer per hour, right, distance is equal to s into t, speed into time. So if he travels at 10 kilometer per hour, he reaches at 2 p.m. Let us see, let us suppose that the Robert has taken t time to reach to reach the place. Okay. So if he's moving at 10 kilometer per hour, he'll reach there in t time. And if he's moving at 15 kilometer per hour, so he is able to reach there 2 hours before the scheduled time. So can I write it as t minus 2? Right. I don't know how much time. I don't know how much time he has taken and how much time before 2 p.m. he has started his journey. Right. But what we know is that at 10 kilometer per hour, he reached that point at 2 p.m. and 15 kilometer per hour, he reached at that point at 12 p.m. So there is a difference of two hours in the journey in both these speeds, right? So now you just have to take this and calculate. So yeah, so 10 into t is equal to 15 into t minus 2. So this would be 10t is equal to 15t minus 30, right? So from here you'll get the value of t as 6 hours, right? T would be equal to 6 hours. And if t is equal to 6 hours, then they are asking us that at what speed must he travel to reach there at 1 p.m., right? So he wants to cover that journey in t minus 1 hour. What is the meaning of 1 p.m.? 1 p.m. is t minus 1, because t was the time till 2 p.m. So at 1 p.m. it would be t minus 1 hour. So he wants to cover the same journey in 5 hours. So how much time he would take? So 10 into t, just put the value of t here and calculate the distance. So t is 6 hours, 10 into t would be 60. So there is a distance of 60. So this distance of 60 you want to cover in 5 hours. So distance divided by time will be equal to speed, right? So that the speed would be 12 kilometer per hour. I hope this is done. Okay, let's go ahead to the next question. Question number 5. Question number 5 says that it takes 8 hours for a 600-kilometer journey. Antonio, I actually can't repeat each question because that would not be fair for all others watching this, right? Because I'll be repeating the same content. You would get this video recorded just after this class, right? Within 15 minutes maybe. So you can rewind it. You can replay it from the question that you want to see again. Okay. Yeah, for now, I'm moving ahead. It says that question number 5 says that it takes 8 hours for a 600-kilometer journey if 120 kilometer is done by train and rest by car. Okay. So we know that the distance is equal to speed into time. Time is speed equal to distance upon time. So 600 kilometer, the journey of 600 kilometer is done in 8 hours when 120 kilometer is done by car, sorry, train, and rest by car. So let us assume that the speed of the train is st and the speed of the car is sc. Okay, st and sc, or we can simply take it as t and c. Speed of the train is t and speed of the car is c. Simple. Okay, right. So in the journey of 600, 120 kilometer is done by train. So 120 kilometers divided by speed of the train. Right, this is the time taken by train plus 480 rest is done by car now. So 480 divided by c. Right, we are calculating time, which is distance by speed. Time is equal to distance by speed. So distance 120 divided by speed of the train, distance 480 divided by speed of the car, right, is equal to 8 hours. This is what they are saying, that it takes 8 hours for a 600-kilometer journey if 120 is done by train and rest is done by car. So this is the first equation. Now, second equation would be it takes 20 minutes more if 200 kilometers is done by train and rest by car. So if 200 kilometer of journey is done by train plus 400 kilometer of journey is done by car, then it takes 20 more minutes. So what is 20 minutes in terms of hours? 1 by 3. So it should be 8 1 by 3 hours. It should be 8 1 by 3 hours. Okay. Now you have to solve this and calculate the answer. Right. This is what you have to do. You have to solve this and you have to calculate the answer. Correct. So now how can you do this? If we just want the ratio of speeds of a train to the car, right? So what we can do is we can make it just a second. No, we will have to solve the equation as only. We don't have options to divide it and take it in the ratio. Okay, so if we don't have any choice, we have to calculate. We have to do this equation. We have to solve the equation only. So can we change it 8? Can we change this 8 1 by 3 to 25 by 3? So we can change it as 25 by 3. Correct? Okay, now 120 by T, 480 by C, and here it is 200 by T and 400 by C. Okay, so what you can do is, yeah, what you can do is you multiply the first equation by 5 and you multiply the second equation by 3. Correct? First equation by 5 and second equation by 3 to solve this. So this will become 600 divided by T is equal to 480, sorry, not equal to, plus 480 into 5 is 2400 divided by C is equal to 40. This is the first equation. And the second equation became 600 divided by T plus 1200. 400 into 3 will be 1200 divided by C is equal to 25. Correct? Right. Now we can subtract this very easily. We can subtract this. So if this is subtracted, so 600 by t, 600 by t would be gone. And this will be 2400 by c minus 1200 by c. So it would be 1200 by c is equal to 15. 40 minus 25, 15. Right. So from here you'll get the value of c as 1200 divided by 15, and that would be 80. 80 kilometer per hour. The value of c would be 80 kilometer per hour. I hope this is done. Can we use 120 minus? No, you can use obviously 120 by s minus 2. Satyam, you can use this, but eventually you have to form the other equation as well, because you need the value of t also. No? So if eventually we have to solve two equation, then the two equation can be anyone. Then those two equation can be anyone, right? It doesn't matter. Yeah. Okay. So C is done. 80. Now just put the value of C in the first equation here. So from here you'll get 120 by T is plus 480 by 80. 480 by 80 is equal to 8, right? 480 by 80 would be 6, and from here you'll get 120 by t is equal to 8 minus 6, that is 2. So the value of t would be 60. Value of t would be 60, right? Yeah. So you'll get the value of the ratio as 3 is to 4. As you can see, the ratio of train is to car is 60 is to 80, which is 3 is to 4. Right. Yeah. And if we had to calculate only one speed, right, then we would have done something shorter in this. But if two speeds are required to be calculated, then I don't think there is any way of cutting it short. Okay, last one. Question number 6, it says two trains running in opposite direction cross a man standing on the platform in 27 seconds and yeah, and 17 seconds respectively, and they cross each other in 23 seconds, right? So for this you need to know the formula of train crossing another train, train crossing a man, uh, and train crossing a platform is not required, but you need train crossing a man in which time is calculated. I hope you know this, that in case of train crossing a man or a pole, right? If man is standing, that can be considered as a pole. So train crossing a pole, the time is calculated as length of the train divided by speed of the train. And while we talk about train crossing another train in bracket opposite direction, train crossing another train opposite direction. Now this formula is time taken is equal to length of first train plus length of second train divided by speed of first train plus speed of second train. These are the two formulae that you need to know to be able to solve this question number 6. Okay, now it's all easy. The case is, now this is an important question, student. Suppose this is a platform. Okay, this is a platform. Yeah. And on this platform, a person is standing right here. A person is standing here, that can be considered as a pole because he is standing, obviously. Right. One train is crossing this platform like this, in this direction, and another train is crossing the platform like this in the opposite direction. Right. Okay, so now as you can see, there are three different crossings. If you are able to notice that there are three different crossing. This train one is crossing this man, this train is crossing this man, and this train is crossing this train. Both trains are crossing each other. Okay, so there are three types of crossing. So let us assume that the length of this train is L1 and speed of this train is S1 and this train is T1. The train 2 has a length of L2 and is moving at the speed of S2. Okay, and there is a man standing on the platform. So first case would be this train crossing this man, right? And by this formula, we can we can calculate that the time taken by the first train to cross the men would be length of the first train divided by speed of the first train, which is given as 27 seconds. Right. Now, put this formula again in case of length, the train 2 and the men. The train 2 and the men. So the time taken by crossing the other train, this let us consider this as T1 and this as T2. So this would be length of the other train, second train, divided by speed of the second train, which is given as 17 seconds. Okay. Now, if we forget this min and the platform also, so this train is actually crossing this train, right, in the opposite direction. So we can say that according to this formula, the time taken by one train to cross another train, let's name it as T3, is will be given as length of the first train plus length of the second train divided by speed of the first train plus speed of the second train, and which is given as 23. It is given as 23. Right. Now, next step would be uh, to take the value of L1 as 27S1 and put it here in place of this. So this will become 27S1 plus, take the value of L2 as 17S2, right? So this would be 17S2 divided by S1 plus S2 to keep it equal to 23, right? I hope this is clear. Put this as L2, 17S2 divided by S1 plus S2 is equal to 23. This is the equation that you need to solve to calculate the value of S1 by S2. You will easily be able to calculate it. This would come as 3 by 2. Right. I leave this question to you because this is something that you need to solve yourself. Right. You should not be dependent of calculation on anyone. So you should be able to solve this. Right. So students, that's it from my side in this video. I'll see you maybe on Sunday with the next video. Right. Of 5 or 6 more questions, and that would probably be on time speed distance only, because time speed distance is not such a small topic that it can be completed in one lecture only, one assessment only, right? So we would be having another assessment on time speed distance only, right? So meet you on Sunday, right? Till then, bye bye, good night, thank you.